In this video, maximum area. So we're going to find the maximum area using quadratics. So let's say that we have Old MacDonald had a farm, and he lived in a van down by the river. He buys 1,200 feet of fencing. And he's going to use the river as one side of a rectangular pen that he is going to create. So here's going to be my very crude drawing here. Here's my river. And here we're going to have three sides of our pen. I can label these variables A that I want. So I'm just going to use X and Y. And this is going to be X. So we have two equations that we're going to have going on here. First of all, we want to maximize the amount of area that Old MacDonald can have for his pen. So the area is going to be equal to X times Y. And the area of a rectangle is going to be length times width. That's pretty straightforward as well. The perimeter, or the amount of fencing that he has, that is going to be equal to 1,200. And that is equal to two of these X values here and here. So we have two lengths of X plus one length of Y. So now the challenge is to take this equation here, which gives us a restriction on the amount of fencing that we have, and put it into this equation here, which is an equation for my area. My area here, it's a function of two variables here. And in order to use the vertex formula, it needs to be a function of one variable. So I'm going to take this equation here and I'm going to solve it for y by subtracting 2x from both sides. And I'm going to get y is equal to minus 2x plus 1,200. Now, I know what y equals. So I'm going to directly substitute that in for y. And I'm going to have A is equal to x times this quantity here of minus 2x plus 1,200. Now, because this is a function of one variable, I can write this as A of x. Great. Now I'm going to multiply this function out. I'm going to get minus 2x squared, doing x times minus 2x, plus x times 1,200, that's going to be 1,200x. Now I have a quadratic. With my quadratic now, I can find my vertex. And my vertex is going to give me two pieces of information. It's going to be what value of x gives me my maximum area, and then the y-coordinate is going to be the actual maximum area. So, using my formula to find my vertex of minus b over 2a and f of minus b over 2a, I'm going to put the values of a and b into this equation here. So I'm going to have minus b divided by 2 times minus 2. So I'm going to get 1,200, divide that by 4, and that's going to give me 300. Now I can take that value of 300 and put it back into my function for my area that I've created. So I can do A of 300 is equal to minus 2 times 300 squared plus 1,200 times 300. So I'm going to use a calculator. Minus 2 times 300 squared plus 1,200 times 300. And I'm going to get an area of 180,000. So this gives me two pieces of information. X is equal to 300. My area, my max area, or my area at 300 is equal to 180,000. So if I go back to my diagram, I can recognize that this part here is 300. This part over here is also 300. To figure out what y is, I can take 300 and 300 adds to 600, subtract it from 1,200 feet of fencing, and that's going to give me 600 here. Or I actually have an equation that's immediately solved for that. Y is equal to minus 2 times 300 plus 1,200. That's equal to 600 as well. So in this case here, I also know that my y dimension is 600. So my pen is 300 feet by 600 feet, and it gives me a maximum area of 180,000 square feet. And this is a classic maximum value problem.